Hello all, in this video we will be discussing a problem based on method of joints. So this is the truss that we have given. There are three loads, one of 1000 Newton, one 3000 Newton and another of 4000 Newton. These are three equilateral triangles and the distances is 10 meters and 10 meters. So before solving we have to determine whether this truss is determinate truss or indeterminate truss. So to determine whether the truss given is determinate or indeterminate, we have an equation m equals to 2j minus r, where m is the number of members in a truss. So this is 1, 2, 3, 4, 5, 6 and 7. So there are total 7 members in this truss. J is number of joints. Number of joints is, this is first, second, third, fourth and fifth. So this is 5 joints. J is 5 and R is number of reactions developed. So at A there is a roller support. At a roller support there is one reaction developed which is perpendicular to the plane. So it will be like this, vertical reaction at A. And at E it is a hinge support, so there would be two reactions developed. One would be vertical at E and one would be horizontal at E. So number of reactions developed is 2 and plus 1, 3. Now we substitute these values in this equation. M is 7 and 2j minus r will be 2 into 5 minus 3, which is 10 minus 3, which is 7, and this is equals to m. So this truss satisfies the condition of m equals to 2j minus r. Therefore, this is a determinate truss. Therefore, it can be solved using conditions of equilibrium. The first step to solve this problem is we have to consider the FBD of the entire truss. So step 1, consider the free body diagram of entire truss. We have these three equilateral triangles here. There is a 1000 Newton, a 3000 Newton and a 4000 Newton load acting on three joints. So this is 1000 Newton. Here you have a 3000 Newton and here you have a 4000 Newton load acting at three joints. At support A, on support A there is a roller support, so there is one reaction developed which is vertical at A, and at point E there are two reactions developed. One will be vertical at E and one will be horizontal at E. The distances given are 10 meter and 10 meter. Now we drew the free body diagram of truss. Step 2 is to apply the conditions of equilibrium. We apply the conditions of equilibrium on this entire truss. You can say this is a general force system. So we have three conditions of equilibrium. First is summation of forces in x equals to 0. Considering forces acting towards right to be positive, there was only one force which is horizontal reaction developed at E, and there are no other horizontal forces, and this is acting towards left. So minus HE equals to 0 or HE equals to 0. Okay. Then we have another condition which is summation of forces in y equals to 0. By considering upward acting forces as positive, we have VA which is acting in upward direction, so that will be positive, plus VE which is acting in upward direction, so even that we will consider as positive, and three forces acting in downward direction, so minus 1000, minus 3000 and minus 4000 equals to 0. So from this we will get VA plus VE equals to 8000, right? This will be, let this be your equation 1. We have one last equation, that is taking summation of moments about any point to be equal to 0, considering anti-clockwise moments to be positive. We consider anti-clockwise moments as positive, and the moment about any point on this entire truss should be equals to 0. So let us consider summation of moment about point E. If I take summation of moment about point E, I will have moment of force VA going in clockwise direction, so that will be minus VA. The formula for moment is load into perpendicular distance, so VA into 20. Then you have 1000 Newton load. That 1000 Newton load is going in anti-clockwise direction, so that will be positive 1000 into what will be the perpendicular distance. This is an equilateral triangle, so this is 5 and this is 10, will be 15 meters. Then you have 4000 Newton again going in anti-clockwise direction, so plus 4000 into, it is acting on a joint at a distance of 10 meters from E, and at last you have 3000 Newton again going in anti-clockwise direction, so that will be plus 3000 into 5 equals to 0, right? So we will get VA. On solving this, you will get the value of vertical reaction at A as 3500 newtons. On solving this, you will get the value of VA as 3500 newtons, and therefore what will be the value of VE, 8000 minus 3500, so it comes out to be 4500 newtons. Now that we have determined the vertical reactions developed, we have to determine the member forces developed in each member of this truss. So we have members AB, BC, AC, BD, DC, CE and ED. We have total number of members as 7. So we have to determine the member forces developed in all these 7 members. We have to solve this using method of joints. To solve any truss using method of joints, we consider a joint with minimum number of unknowns. Now at joint A, if I see, I have one unknown force which is vertically upward, one inclined force which is unknown, and one horizontal force which is unknown. At joint E, I have one horizontal force which is unknown, again one horizontal force which is 0, so that is not applicable, one vertical force VE, and one inclined force. Let us consider joint A. This is our step 3. Step 3. Consider the free body diagram of joint A. On joint A, there are 3 forces acting. One is your vertical reaction at A, which was 3500 Newton. One is horizontal force in member TC, so this is your FAC, and one inclined force in member AB, so this is your FAB. Since these member forces AB and AC are unknown, we consider them to be tensile forces. So these are all tensile forces. This is acting at an angle of 60 degree. This is your joint A. Apply conditions of equilibrium. Your step 4 will be to apply conditions of equilibrium to joint A. Now this is a concurrent force system, so we have only 2 conditions of equilibrium. One will be taking summation of forces in x equals to 0, considering forces acting towards right as positive. Here you have one inclined force of FAB. Its horizontal component will be FAB cos 60 and its vertical component will be FAB sin 60. right? Since the angle is given with respect to horizontal, the horizontal component is cos and vertical component is sine. Both the forces are acting towards right, so you will have FAB cos 60 plus FAC equals to 0. Let this be your equation 1. We have another condition of equilibrium, which is summation of forces in y equals to 0, considering upward acting forces as positive. We know that A is acting in upward direction, so this 3500 will be positive, plus FAB sine 60 and equals to 0. On solving this, you will get the value of FAB equals to minus of 4041 newtons. What does this minus sign indicate? This minus sign indicates that since we've considered force AB tensile, it is not actually a tensile and it is a compressive force. So FAB is actually 4041 newtons of compressive force. The sign indicates that the assumed direction of the force is wrong. The sign indicates that the assumed direction of the force is wrong. Since we had assumed it to be tensile and the answer and the value came out as negative, that means that the force is actually a compressive force. Now, if you look here, we have considered forces acting towards right as positive. From this, you will get FAB cos 60 minus FAB cos 60 plus FAC equals to 0, and then we will get the value of FAC as 20 Newton, and since this value is positive, that means it is a tensile force. So this is how you determine the value of member forces. Now here we know we had determined the value of members AC and AB. Right? Now let us move to next joint. We have to determine the forces in every joint. So let us move to next joint. Consider joint B. Okay. So we will have our step 5. Step 5. We will draw the FBD of joint B. On joint B, there are 3 unknowns, BA, BC and BD. You have FBA, FBC, FBD and one vertically downward acting force of 1000 Newton. Right? One vertically downward acting force of 1000 Newton. Now this FBA and FAB will be same, right? This is the same member. So FAB is 41 newtons of FAB, FBA is 41 newtons of compressive force. So it will be acting like this, right? And FBC is unknown, so we will consider it to be tensile. This is 60 degree and this is also 60 degree. Again, step 6 will be applying condition of equilibrium. We have summation of forces in y equals to 0. If you take summation of forces in y equals to 0, you will have components of two forces. One will be FAB sine 60 and one will be FBC sine 60. This is compressive and this is tensile, so the component is acting in downward direction and this component is acting in upward direction. Now, taking summation of forces in y, considering upward acting forces to be positive, we will have FAB sine 60 plus 1000 minus FBC sine 60 equals to 0. Right? On solving this, we will get the value of FBC. On solving this, we get the value of FBC as approximately equals to 2886 newtons, and since this value is positive, that means the assumed direction is right. That means this force BC is actually acting in tensile direction. We have to find this FBD. To determine FBD, let us take summation of forces in horizontal direction to be 0, considering forces acting towards right as positive. Now we will have horizontal component of FAB. This will be FAB cos 60, and this will be FBC cos 60 and FBD. So while taking summation of forces, we will have all these forces we have considered to be acting towards right. So you have FAB cos 60 plus FBC cos 60 plus FBD equals to 0. On solving this, we get FBD to be minus of 3464 newtons. Since it came out as minus, that means the assumed direction is wrong, and that means FBD value is 3464 newtons of compressive force. Okay, so this is how we determined the value of members FBD and FBC. Now we have these three members remaining. Let us consider joint C. That will be our step 7. Step 7, we consider the FBD of joint C. On joint C, you have one vertically downward acting force of 4000 Newton, one horizontal. This AC we already know, BC we know. We have to determine CD and CE. So on joint C, we have vertically downward acting force of 4000 newtons, one horizontal force AC. This AC is tensile force, so force AC is tensile, FAC. This force BC is also tensile of 2886 newtons. This is unknown force CD. This is unknown force CD, and this is unknown force CE. This is making an angle of 60 degree, and this is making an angle of 60 degrees. Right? FAC, the value of FAC was 2020 newtons. So we will write it this is 2020 newtons. Now we have to apply conditions of equilibrium. Applying summation of forces in Y to be 0, considering upward acting forces as positive, we will have to resolve these two forces. This will be 2886 sine of 60, and this will be FCD sine of 60. Both these forces are acting in vertically upward direction, so those we would be considering as positive. We will have 2886 sine 60 plus FCD sine 60, and this 4000 is going in downward direction, so that is minus 4000 equals to 0. Now on solving this equation, we get the value of FCD as 1732 newtons, and this value came out to be positive. That means the assumed direction is correct, and that means this is your tensile force. This is how we determined the value of FCD. Now we have to determine the value of FCE. To determine the value of FCE, we will take summation of all the horizontal forces to be 0. Forces acting towards right would be considered as positive. We will resolve these inclined forces in its horizontal component. It will be 2886 cos of 60, and this will be FCD 1732 cos of 60. Since we know the angle with respect to horizontal, its horizontal component are considered as cos. So while taking summation of horizontal forces, 2020 is acting towards right, so it will be minus 2020. 286 cos 60 is acting towards left, so it will be considered as minus 2886 cos of 60. 1732 is acting towards right, so it will be considered as positive 1732 cos of 60, and FCE is acting towards right, so again positive FCE equals to 0. On solving this, we get the value of FCE as 2598 newtons. This 2598 Newton, the value is positive, that means the assumed direction is correct, that means this force in CE is tensile force. Now we have determined the value of CD and CE. Now only one member is remaining, which is joint E, which is member DE. So let us consider summation of, this is our step 8. We will consider FBD of joint D. On joint D, you have one downward acting force of 3000 Newton, one force BD, this is force BD, one force CD, and one force DE. This is of magnitude 3000 Newton. Magnitude of force CD is 1732, so we will write here 1732, and force BD, the magnitude of force BD is 3464 of compressive nature. Since the force is of compressive nature, it will be acting like this, and the magnitude will be 3464 newtons. This is making an angle of 60 degrees, and this is making an angle of 60 degrees by your alternate angle theorem. Sorry, this will be making an angle of 60 degrees. Yes. So now we have conditions of equilibrium, taking summation of forces in X and summation of forces in Y. So if I take summation of forces in vertical direction to be 0, if I take summation of forces in vertical direction to be 0, considering upward acting forces to be positive, I will first resolve these forces. 1732 vertical component will be 1732 sine 60, and FDE vertical component will be FDE sine 60. So while taking summation of vertical forces, I will have 3000 Newton acting in downward direction, minus 3000 minus 1732 sine 60, and minus FDE sine 60 equals to 0. This 3464 Newton per force is perfectly horizontal, so we are not considering that. Now to determine the value FDE, on solving this we will get the value of FDE as minus 5196 newtons. Since the value is negative, that means the force acting on member DE is of magnitude 5196 in compressive nature, and the force is of compressive nature. So that is how we determine the value of member force DE as well. Okay, thank you.